have a very exciting speaker for you. We have our CTO, Sasha, and he's going to talk a little bit about some upcoming teleport features that are coming out around 2023. And that's going to be device trust and policy as code. And yeah, I'll let Sasha take it away. Thank you so much. Big round of applause for Sasha.
Hello, everyone. I have talked to many of you about technology, and I'm excited today to show two very interesting projects, not the most important ones, maybe not the most important ones in 2022, but we think they will be really important in 2023 and 2024, because they not only solve really important problems, but kind of explain our vision to solve issues that we have seen with security, different types of attacks, policies as code, and so on. But before I begin with this, I have my usual questionnaire. Can I ask the audience a question? So how many of you are using Vim as your main editor? Can you raise your hand? All right. So we have 10 folks. All right. How many of you are using VS Code as your main code editor? All right. VS Code. All right. And how many of you are using the best code editor there exists, Emacs? All right, 2? All right, yeah, I've been writing this questionnaire for several years, just curious what is the trend? Definitely not in the direction of Emacs. I can tell you. Okay, so it's the end of almost the end of our conference, right? And everyone is a little bit tired, so we will keep this kind of informal and focused on the live demos instead of really long presentations. They're really two cool projects. The first one is called Device Trust, and we will start just with a demo explaining and showing kind of how we think about making sure that not only users provide their identity when connecting to something, but also devices can provide their identity when connecting users or connecting on their own as machines. And when we've been thinking about this problem in general, some of you have, actually, let me ask you another question. Have you used some sort of device attestation or device trust services before? All right. And for those of you who never use those services, they're trying to solve a really important problem. How can I trust your device, right? Have I seen this device before? And the biggest issue with those solutions that we've seen in the market is that they literally just put private key and cert most of the time on your computer. And this is the extent to which the trust is formed. And in the latest years, there has been an innovation done in the hardware, actually. If you look at Mac or ThinkPads, they have really powerful security devices, secure enclaves that store the private keys that cannot be exfiltrated without actually, if you even try to break this device, you won't be able to exfiltrate the private key material. And we wanted to take advantage of this new technology and build a lightweight but really powerful solution to demonstrate that the device can be trusted. And we will try to demo it today. It's very early. It's coming like in 2023 Q1, so things might not be as polished. So I'll let Ben take it away and show, please.
Thank you, Sasha. Nothing quite like some pre-demo gods happy hour action. Can you see my screen? Yeah. So one of the first things I'm going to show you, when we're talking about device trust, involving the device, each machine has a unique serial number. And Macs with the secure enclave, this is a direct mapping. So here I'm going to use tcuddle device ls. And you can see I have two devices here. One of them, which is actually my machine, which is being enrolled, and one that is not enrolled. And what this means is during this enrollment process, you have devices as an administrator, so you know your whole fleet of Macs, or even if you bring your own devices, you tell people to send your serial number, you enroll them, and then there's a TSH command that they do to do this enrollment ceremony, which, as you can see here, is quite transparent to the end user, but it sort of goes and signs everything on the secure enclave. Within the Teleport cluster itself, This is probably familiar to lots of people under our auth service. We've been adding and improving WebAuth and endpoints. We recently added passwordless, and you see here that we have a new addition, which is device trust. This can be optional or required. If you make this required, the only machines that can connect to hosts have to be enrolled. And once the host has been enrolled once, it's the same login procedure. I'm going to do login, and everything is pretty much the same. It will just trust this device both on the CLI and in the web UI, and there's a few extra extensions that we've added, like asset tag, credential ID, and a few other things. But as an end user, everything is pretty much the same. So that's sort of the end of the device trust demo. If you have any questions, feel free to ask me at the end. Or Joe, you can just ask me now.
Yeah, we have started with macOS Secure Enclave, but the next one on the list is ThinkPads with their TPMs and Windows Hello integration. Yeah.
Eddie?
What's the enrollment process look like in the automated?
You need to get the person to run the command on their machine. Actually, if I come here, there's a device, TSH device enroll, and we can try this. Why not? Let's do it live. Okay. So I'm going to add a new device. And then you see there's this device ID tag, or maybe it's the token, that you do a TSH device enroll, and then you do that one time, and then that device is enrolled. So there is like some end user action that needs to happen throughout the ceremony.
We will start integration a little bit later once we figure out the actual Windows stuff, because it's probably going to take us a while. So macOS was kind of nice and easy, but we know that Windows is a little bit harder than that. But yeah, then we will work with MDM integration. Mm-hmm.
Okay, I'm going to pass over to Sasha for Predicate.
So this is an interesting project. I started working on it actually 4 years ago, trying to solve the problem that I've seen in the industry. So before I begin explaining what it is, let me ask you another question. I know there's a lot of questions. How many of you have ever used something like AWS IAM policies? Can you raise your hand? All right. And you know it's all JSON, right, and declarative programming. Okay. And how many of you have used something like Open Policy Agent, a new programming language, exciting one? Okay. So some folks have used it, but obviously not as used as AWS IAM. So if we think about policies in general, access policies in general, there are a couple of things that we like about them. And for folks who are not aware of what access policies are, those literally are expressions in any programming language, or maybe JSON or YAML most of the time. If you worked with Teleport, you used YAML, and if you used AWS, you have used JSON. They're most of the time declarative, not imperative. It means that you declare the state, like who theoretically should be granted access or denied access, or whatever actions they're allowed to do or not. And then you deploy them. And then, magical system behind the scenes figures it out, right? So we are all used to that world. And it actually started way before AWS IAM. If we go to the beginning of this story, it's actually 1960s with teams, they're called Tiger teams, that were working and building those access policies for the first Linux-like operating systems. And then we're obviously all familiar with IP tables. Those are also declarative policies, right, that allow us to deny or allow access to specific ports, network interfaces, and so on. So this is all an evolution. However, I'm a developer, so I started as an engineer and spend most of my time programming. So there are a couple of things that I'm missing every time I work with policies, Teleport policies or otherwise, or AWS IAM. The first thing that I'm really missing is a real programming language, right? JSON is cool, right? But I just really like autocomplete, test frameworks, and that part was really missing for me. And when we looked around in the existing ecosystem, we couldn't find anything that kind of resonated with us, because sure, new programming languages are all cool, but where is my test framework, right? Surely JSON is portable and I can transfer it everywhere, but how can I actually make sure that the policy that I wrote is doing exactly what I want in the way that is familiar to me, which is writing tests, and then share it with someone and they can contribute, again, update tests, classic test-driven programming, right? We're really missing that. So today I want to demonstrate our approach to it. This new project, Predicate, it's a very new project, so it actually hasn't been released officially as an open source project yet, so it's the first time we're hearing about it. You're hearing about it as well, but it's already an open source repo, so it's called gravitational predicate/lang, and you can take a look at it. So let's start with the policy. In this case, I'm using Python, but Predicate is actually language agnostic. You can use any programming language that you want that integrates with one tool that I will announce later. I just chose Python for the initial implementation because it's an easy language for creating your own domain-specific languages. And the important thing about Predicate is not a programming language. It's not a data structure, and that was the most important thing for me. I didn't want to create a new programming language specifically for that purpose. I wanted developers to use their favorite one, whatever it is, Rust, Python, JavaScript, TypeScript, whatever resonates with you. So let me start with the evolution of how, as a developer, you would approach building in this Predicate environment. I switched to VS Code just for you all, right? I'm so sorry for not understanding all the shortcuts. Oh, I don't know how to do that actually in VS Code. Oh, let's try that. Here you go. All right. So the first thing I want to do is just to create a policy and deploy it, right? So in this case, this is my policy and that's how I've deployed it. There's nothing unusual about it. And in this case, it deploys it to Teleport itself. And let's see how that policy works. So I'm going to log in. I'm going to showcase Teleport user nameless and passwordless login. So in this case, literally policy doesn't allow me to do much, right? So I'd like to add some functionality, and I'm just going to be honest with you, copy paste just for sake of time. And because I don't know how to type in VS Code. Let's do that. Okay, so this one, let me try to deploy it and see if that works. Okay, that is deployed. So in this case, what I've done is it's very, very simple. I created a declarative statement that allows whoever holds that policy to get access to resource kind node, which is Teleport specific stuff, right? You have nodes, you have Kubernetes clusters, but you can imagine this could be any resource you really want, right? And the statement here, I think, is you can understand it as a developer or as SRE engineer or as a DevOps because it's really just a logical statement, right? There's nothing special about it. It says, we allow you to access our resource kind node in this namespace. And I can see if that works. Okay, that works, and let me see if I can connect with that resource. Give it a second. All right, so in this case, the access has been denied because I haven't actually specified that I can see the resources, but I cannot connect to them. And it's kind of still familiar to all of us, but let's see how that evolves with our imagination, right? How we can imagining the new flow of building and developing access policies. So in this particular instance, I have deployed it, and let me try again. All right, I was given access, and this nothing unusual, but what I'm missing most of the time is just having this ability to use autocomplete, to use my favorite tool, to run policy to check syntax for me, and just iterate quickly over it. So that's the first thing. However, this is on its own is not enough. For any of us who wrote any production-grade system, we know that this won't pass any pull request review from our peers, right? And I think we all know what's missing. Well, the tests are missing, obviously. So I'm just going to copy-paste those tests. So the first thing I want to validate is something obvious, right? I want to know that the policy actually is doing something I have asked it to do, just in case if some developer who will be contributing to this will understand my intent. And let me see if I... Okay, so I messed up the Python indentation. Here's me praising Python. All right, so in this case, let us review what is happening here behind the scenes. What is happening here and what's happening behind the scenes. Here's literally I'm verifying that if my username is Sasha, I can log in to the nodes with the SSH principal Sasha. This is a statement that I think we can all recognize, right? And it's a very simple first step to ensure the invariant of whatever policy we're writing. You can imagine those tests will be more and more complicated as the system grows, and I would like to show you this evolution as well. However, on its own, this is not actually enough for us. As security engineers, we need to not only prove that the obvious invariant holds, we also need to prove that the evolution of this invariant, or maybe some different permutation of this invariant holds. So what we really care about is actually this. So that's the question that I'm really interested in. So does this policy set allow anyone with any permutation to get access as a root to the infrastructure? And that's a different kind of test. It actually does not ask us to just input parameters that the policy expect and give us yes or no answer. It is a different type of question, right? So it's not kind of the question we're usually asking as engineers the program that we wrote, right? It's a little bit different type of question. So let's see. So in this case, no, this policy under no circumstances will allow anyone access as a root to this infrastructure. So as our policies evolve over time, we would like this test, this line, to always be there. Whatever else, new parameters I add, whatever labels I add, this should not grant anyone production access as root. So how does it all work? Like how Teleport Predicate can magically answer that question? And the answer is Predicate or Teleport doesn't actually answer that question. There's another project that Predicate is built on top of that answers that question for us. And the reason I'm so confident in that answer is because behind the scenes we have built a theorem. So this theorem is built, it took this logical expression and built, you can imagine it as a very long Boolean logical expression. And using the project from Microsoft calling Z3, it has asked for counterexample of the statement, and we got answered there's no counterexample in this case that it was able to find using a variety of techniques that Z3 deploys to find answers to that question. And that's the power of Predicate. Really doesn't come from the Predicate itself. It comes from the amazing research that the Microsoft engineers have done. If you have seen that research used elsewhere, you might take a look at AWS project Zelkova. They are using very similar approach to give you more nuanced answers about the policies that you write. For example, is this policy equivalent to another policy? It's not the same, not identical, but does it provide the same results? So let's take a look. I will stop coding or copy pasting and I wanted to finish this presentation with just a little bit of a overview of what else Predicate can do for you today, and how can you integrate it in your own project as well. So the first one, I was really curious about the equivalency tests, because I really wanted to know for example, this policy is redundant. Maybe I made a mistake, right? Or maybe I made a typo. And one of those possible ways to answer is if you write two policies, you can build those two theorems and asking, well, are there any different outputs of those two expressions? And there is no different outputs. You can safely say that those two policies are equivalent. In this case, we can see that clearly I made a mistake, and I basically duplicated policy. So it's redundant, and it could be simplified. And that's exactly what Predicate can do in very simple cases, and can actually simplify the policy for you and give you an equivalent, much simpler policy that you think that will work in exactly the same way. That is really important for us as security engineers, because we will not only see what we wrote, but we will also see what actually will happen as if we deploy this policy. So we think we know how it works, but Z3 will give us somewhat, not a perfect, obviously, there's no perfect solution to the problem, but more nuanced answer of what actually will happen with this equivalency tests. And finally, I want to say that Predicate is not a system that is encapsulated and works only with itself. Because Predicate basically is a library that compiles to Z3, and it's an open source project, you can integrate this in your favorite system as well. In this case, I'm demonstrating this by converting S3 policy to Predicate expression and using basically tests using Predicate to answer different questions about AWS policy. So I import, you can imagine this, importing AWS policies that you wrote, IAM policies, and then starting asking questions compiling this to Z3 theorems and getting answers. So that's why I think Predicate is cool and interesting, because it helps us to solve all those unanswered questions or problems that we as security engineers, developers, SRE, system administrators have been struggling with, precisely because we didn't have the tool that was built by this amazing team. So really, all credit should go to Z3 and Microsoft research team for this. And however, I think we can all benefit from this amazing research by trying to build something interesting and exciting for the projects that we work on. So you would expect Predicate to be in preview in early 2023. But you can also send your PRs, contribute, ask questions, and maybe collaborate with us on it. Thank you very much.
Thank you. Thank you so much, Sasha. That's super cool. That's amazing. Are there any, do you want to take some questions?
Sure, yeah.
Does anyone have any questions for Sasha?
So this is great stuff, and anybody who's used Rego would love something like this to assist us. But how did you get the translation from Predicate to a teleport policy? And how would I convert that to maybe a Rego or some other thing? Is there extensibility aspects there? Thank you.
So the question is basically how, giving the Predicate expression in Python in this case, or let's say another DSL written using Rust or TypeScript, how do we convert it from to platform-specific representation? So in this case, the answer is this expression is declarative. We create an abstract syntax tree, and then we traverse this tree to emit whatever is relevant. In this case, those are literally teleport RBAC policies, but you can also imagine emitting something else, AWS IAM policies, or Rego policies, or even, we've tried this with WASM, didn't go well, but we expect maybe in the future we'll be more successful with WASM integration in Teleport, so that could be WASM programs. And you can write your own converter right now. So you can take this, think of it as a DSL with abstract syntax tree that you can traverse and build your own transpiler. All right, any other questions?
All right, let's give it up for Sasha again. Thank you so much.